Welcome to Sundar's lecture. This is lecture number 40 and we will continue the topics, what are all the topics we have seen in the previous class, right? So, in the previous class, we have taken AC through series RL circuit. So, an AC supply is given to series RL circuit and we have seen these two expressions, right? VR and VL, and we have got this expression, and what is the total V? That will be is equal to VR plus VL. And we have tried to draw the phasor diagram for the series RL circuit, and in that we have taken I as the reference value. So here you see VR is in phase with the current value, but VL, this is actually VL. I have made a mistake in the previous class. Actually, this is VL. This is VL. I have written it as VR anyhow. So this is actually VL. I have written here correctly. Here I have written correctly, but here I have told it as VR, but I have written it as told it as VL, but I have written it as VR here. Anyhow, so this is the phasor diagram, and we have just shifted this VL to this side, and we have drawn the voltage phasor diagram, or you can call it as voltage triangle, and we have found the values using this triangle. We have seen this one in the power polar form and rectangular form, right? And also we have gone for impedance triangle, and we have got so many important terms of what is the pi value and what is cos pi values, and so many things we have seen in the previous class. Now in this class we try to get what is the power in the RL circuit. What is the power in this RL circuit? I have told you, I have given a hint about the power in the previous class. Because we have R, we should have real power, and because we have L, we should have reactive power. So this circuit possesses real power as well as reactive power. That depends on the value of R and L. We will see that how this expression comes and how we can assess the real power and reactive power in the circuit, right? So for that, first we need to find what is the value of I. So you see here what we have done. Wherever you go, if you want to get what is the value of I, you can easily see this is V and this is I. This is the reference value. If this is V is equal to Vm sin omega t, and what is the I value? I value will be is equal to Im sin of omega t plus this degree plus this angle, right? Plus this angle. That means I and V, there should be an angle, and that angle is pi here, and we would have written this as I is equal to Im sin omega t plus pi, but we know this is 90. Since this is 90, we have directly written it as 90. But here in RL circuit, you can clearly see this is the V curve. Sorry, this is the V phasor, and this is the overall I phasor. And we don't know the angle here. We don't know the angle, but we know what is V. We know what is V. So I will write here anyhow. See, I will write here. I know what is V, right? V is equal to Vm sin of omega t. That I know. But if I want to find what is I, then I lacks the voltage by 90 by an angle pi. See, this is V and this is I. I is lagging actually, right? I is actually lagging by an angle pi. So what I can write here? So I should be equal to we know this one, I am sin of omega t minus pi. That's all. Simple to understand, right? So minus pi. So this is the expression for V and I in the RL circuit. Now we try to get the power expression. So power in RL circuit. So if you want to find what is power, then it is simple to understand, right? How you can write power. P, which is equal to V into I, we know this one. So if you want to write what is V, here it is Vm sin of omega t into Im sine of omega t minus pi, right? We can write like this. So here this Vm sine omega t you keep as it is, you don't do anything with this, and into Im. What is sine of omega t? Omega t minus 9 minus pi can be written as sine a. This is sine of a minus b. Sine a cos b cos a minus cos a sine b. Right? We can write like that. So I will write here sine a. That means here it is sine of omega t. Then I can go for cos b. Cos b here it is pi minus cos a sin b, right? I have written this one, so I will write here anyhow so that you can easily understand. Sin of a minus b can be written as sin a cos b minus cos a sin b, right? I have just written this one. So we have directly written the expression here. Now what we do, we just multiply this term to the inside. That means in the bracket term can be multiplied with this term. So I can write here. So this term which is equal to Vm, I am just writing it as Im because I have multiplied this one, and sin omega t is there. Sin omega t, okay, fine. Sin omega, so Vm, Im sin omega t, I have to multiply with this term. So it becomes sin square omega t. First term becomes sin square omega t with the cos pi. See, Vm, Im, these two multiplied sin square omega t and cos pi. So Vm, Im, cos pi I keep as it is, and this term becomes sin square omega t. Okay, that's all. First term has been completed, and for the second term, I have to put minus. Next one again, Vm, Im, I keeps cos pi here, sin pi here, and sin omega t, cos omega t will be there. So I will write Vm, Im, I just keep sin pi, and what is the other two terms? Sin omega t, cos omega t. So this becomes sin omega t cos omega t, right? So this is the expression. And what is, I will write, what is sin square omega t? So I just write it in a different color. So what is sin square omega t? Sin square omega t or sin square theta. Sin square theta can be written as 1 minus cos theta, cos 2 theta divided by 2. So we have seen this formula, right? Sin square theta can be written as what? 1 minus cos 2 theta divided by 2, because I have omega t, I have written like this. And also you see this is sin omega t cos omega t. Sin a cos a can be written as what? So I will write here sin omega t, and we have cos omega t, which means both are same. So you just imagine that it is sin a cos a. So sin a cos a can be written as sin 2a divided by 2. What is a here? It is omega t, right? So sin 2 omega t divided by 2. Simple, right? So I have written the formulas for both the these two omega t values. Now I can finally write power, which is equal to Vm Im by 2, Vm Im by 2. What is this one? Vm, this 2 I have taken here. Sorry, 1 minute. Vm Im, this 2 I have, instead of the sin square omega t, I have to replace 1 minus cos 2 omega t by 2. I will write Vm Im by 2 cos pi. What is this term? This is nothing but 1 minus cos 2 omega t. That is the first term. I just bring this 2 to this to Vm by Im side. Right? Next one minus, and I need to write this expression now. So in this also I have a 2 here. So what I will do? So here Vm Im divided by 2 sin pi is there into what is this term? Sin 2 omega t. Sin 2 omega, right? This is the final power expression. And you can clearly see that these two 1 minus cos 2 omega t and sin 2 omega t we have already seen. We have already seen, right? Huh? Where we have seen this one? See 1 minus cos 2 omega t. Where we have seen this one? In purely resistive circuit. See what is the expression we have got here? 1 minus cos 2 omega t. If there is a 1 minus cos 2 omega t, whatever the magnitude you have, all the magnitude value will be positive. All the magnitude value will be positive. And what is the average value we have seen? P average will be is equal to Vrms and Irms. Right? Divided by 2. Here we have cos pi, right? Here we have cos pi. So if you take average value of this, what you will get here? Because we have Vm Im by 2, we have got Vrms and Irms. Since we have cos pi there, that is a constant value. See, cos pi is a constant value. If you put what is pi value, then pi value can be anything. Maybe from 90 to 0 degree, pi value can vary in the RL circuit. Huh? So this is the real power term. Real power term. So I directly write here. I directly write. Maybe I will mark this as the first term. This term. This is the first term, and this term. This is the second term. Right. So from pure resistive circuit. From pure resistive circuit. From pure resistive circuit, I will write here this term Vm Im by 2 cos pi is always positive. Always positive, or we can say this is real power. Why we are saying it as real power? Since the power is positive, all the power generated by the source will be received by the load. Right? That is why we are calling this as real power. Right? And what is the average? What is the average value here? What is the term we have got here? This is the Vm Im by 2 cos pi is the value now. And what is this value now? If you divide it by root 2 into root 2, we can write this as Vi cos pi. I don't need to write RMS value. I have told you already. So this is the real power. This is the real power. And you try to understand what is this one? Sin 2 omega t. Where we have seen this in the RL circuit. You take here. See, this is the RL circuit, right? Not RL circuit. This is the pure inductive circuit. In pure inductive circuit, what is the term we got for the power? It is minus Vm Im by 2 sin 2 omega t. So if it is a sin 2 omega t, and what we have got here is the reactive power. The power will oscillate between source and load continuously. So there is no power utilized by the source, and no power utilized by the load. Source generated some power, and that is actually oscillating between load and source. And that power we are calling it as reactive power. That is what we have got here. See, sin 2 omega term. And what is this one? This whole term will be oscillating between load and source, right? So what I can write here, see, so I will write. So from pure inductive circuit, this term, that means minus minus Vm Im by 2 sin pi. This is actually oscillating power. Oscillating power, or we can say it as reactive power, or we can say it as reactive power. And how I can write this one now? So this one Vm Im by 2 can be written as what? Vi. This is Vm by root 2 and Im by root 2. And what is Vm by root 2? That is Vrms and Irms, right? So I can write this as Vi sin pi. Vi sin pi, that is nothing but it is the reactive power. So these are all the two power that we have got for the overall power. So I can write, so the two powers we have that is P which is equal to one power, that is Vi cos pi, and the another power I will write just plus here, I will write just J Vi sin pi. Why I am just writing this one? You try to understand this one very clearly. This is actually Vi. What is power? Power which is actually Vi, and this will be Vi cos pi plus J Vi sin pi. I will write like this because we have seen this one, right? An AC quantity can be divided into two parts. One is cos pi term and one is sin pi term, right? So for that we would have drawn the triangles, right? Triangles can be drawn like this, right? So what is this one? We have seen these kind of things already. See this one. A sine quantity can be drawn like this, right? If this is the total quantity, if this is the total quantity, this is V, this is actually Vi, this is actually Vi, that is power, P is equal to Vi, and we can write like, this is cos pi term, right? That is what we have got here. This is cos pi term, one is cos pi term, one is sin pi term. So what we can do, this one, that is nothing but a Vi cos pi term, and this is nothing but Vi sin pi term, right? We can draw like this. I have told you, right? If this is the Vi, then this can be Vi cos pi, and this can be Vi sin pi, right? And what is this one? This should be pi. You've seen this. If you want to know very deep understanding in this triangles, you just go through my polar and rectangular form lecture video. You can easily get the point of writing this triangle with the expressions, right? So this is now what I will write. Try to understand clearly. This power is the real power. This power is the real power, and this power is the reactive power, and I will call this power as the apparent power. This power will be apparent power, right? This is the power triangle. This is the power triangle. Power triangle, right? We can write the expression like this. That means P which is equal to Vi cos pi plus J sin plus J Vi sin pi, right? So in general, this will not be called as P anyhow. I have written this one as P, but you try to understand. In general, what we will write, apparent power can be denoted by the term S, and real power can be denoted by the term P, and the reactive power can be denoted by the term Q. So I will write here. So it is easy now. So apparent power S is equal to what? This is VI. This is nothing but apparent power, right? Apparent power. Just we need to name this one. Apparent power. And real power, which is P, which is equal to VI cos pi. This is nothing but real power. And Q, which is equal to VI sin pi, which is nothing but reactive power. So these formulas can be frequently used. So you have to understand this type of formulas. And also you see what is this cos pi. Now we need to find what is the cos pi value. Right here for this one you go for cos pi. So cos pi should be is equal to P, that means VI cos pi, that means P divided by S. That means P divided by S, or we can call it as real power divided by apparent power. So we have to note a point here. That means what does this cos pi denotes as? This cos pi term we are calling it as power factor. Power factor. Try to understand. This one is very important. Power factor in a AC circuit gives you an idea. And what is that idea? Try to understand. What is the real power? Real power are all the powers which is utilized by the load. And what is reactive power? Reactive power are the powers which is not utilized by the loads. What is apparent power? Apparent power is the total power given to the circuit. VI, that is VI. So VI is the total power that is given to the circuit. And what is the real power? That is the power utilized by the load. And what is the reactive power? That is the power not utilized by the load. So then what is pi? Cos pi, you see, upon apparent power, we have calculated the real power. How much of real power has been in the circuit, that will be the cos pi value. And that is nothing but power factor. What is power factor? Upon the power we have given, total power we have given, how much powers are utilized by the load, that can be calculated by the term cos pi. And cos pi will tell you what is the real power used. Right? That is the thing, right? You see, you can easily get the value from this expression. Right? P by S, which means what is this one? This is nothing but adjacent side by hypotenuse side, right? Adjacent side by hypotenuse side. And if you want to write what is sin pi now, so I will write here sin pi. Right? Try to get every points here. Try to get every points. What is sin pi? That is nothing but it is the opposite side divided by hypotenuse side. What is opposite side? This is Q divided by S. And what is Q here? What is Q here? Q will be the reactive power. Reactive power divided by apparent power. And what is this term? This term will tell you that how much of power is not utilized by the load. See this one. If this is the power factor and this is the opposite to power factor, that's all. How much of power it is not utilized directly, it is not utilized by the load. So that is nothing but it is the sin pi. So you need to understand what is the cos pi term. I have already told you that the sin pi term and cos pi term will give you so much of idea about the AC circuit parameters. That means this cos pi now, you see this cos pi can be written as a real power by apparent power, and as well as you come here, it can be also R by Z. Resistance by total impedance. What is the total impedance and what is the total resistance? Then what this one, how you can relate these two terms? Only resistive circuit, only resistor will get the real power. And that is what we have got here also. See, this term whatever this term, that means 1 minus cos to omega t will be totally related to resistor, and sin to omega t will be totally related to inductive. And if by the inductor, the real power in the circuit comes, and by the resistor, sorry, by the inductor, the reactive power in the circuit will come. By the resistor, the real power in the circuit will come. So there are so many points we can get through if you draw the triangles. If you draw these triangles, and you can get so many points. Cos pi value, what is the real meaning behind the cos pi term? That is nothing but it is the power factor. And wherever you go, you have to maintain your power factor upon 0.8. There is a restriction to maintain the power factor at 0.8 in the industries. And what is that actually? If you are giving an apparent power of 100, for example, you take a numerical value as 100, you have to utilize 80 in that 100. That 80 should be real power, and I'm not telling very deeply with the SI units because you people cannot understand what I am telling. So 80% of the power should be utilized by the load. That is the thing you need to understand. Okay, fine. We will take up a problem in the next class, and we try to solve that problem. Then you can get so many interesting things in the problem. You please go through these terms. What is cos pi, what is sin pi, and what is power triangle, and what is the real power, what is the reactive power, and so many things comes by RL circuit. We have just combined now, right? First we have seen R, L, C separately, and we have combined RL. Now we are going to combine RC, and we are also going to combine RLC circuit. So we are just going into the AC circuits with a deeper knowledge now. So we will solve problems in the next class so that you will get a good idea about the AC circuits with RLC parameters or RLC elements. Thank you. Go through this one.